Okay, guys, today we will be doing Chapter 2, Lesson 3. It's doing limits analytically with piecewise functions. So let's go forward. Okay, first let's look at the warm-up real quick. It might help us with future things that we're doing in this lesson. When finding limits algebraically, there are how many steps to solving them? There are 3 steps to solving them. First, I have a continuous function. I need to plug in. Remember, you just plug it in at the beginning and hope that it gives you an answer. Sometimes plugging in the value doesn't work because it will divide by 0. Remember, if it divides by 0, that means there is a discontinuity and we have a problem. In that case, I need to factor, then cancel. Okay, remember that gets rid of one of the discontinuities, the removable discontinuity. This will eliminate the removable discontinuity, or another word for that, a hole. Lastly, if factoring doesn't work, the answer is either, okay, remember there's 3 answers. It could be infinity, it could be negative infinity, or it could be d-any. And remember, the reason for those must be because the answer is because the function has a what kind of discontinuity at this point? We already got rid of the hole. The other discontinuity is a vertical asymptote. Okay? So, there are the 3 steps to solving a limit analytically. Remember, we're still going to be pretty much using those on a piecewise function. Okay, define a limit in your own words. I'm not going to write these down because it might take a while, but define a limit in your own words. Defining a limit in my words would be what y value you approach from the left and the right. Okay, the y value that you approach from the left and the right. Okay, let me go back. Okay, define a discontinuity. How I would define a discontinuity is I would say it's a function that does not have an x value somewhere. So a function that does not have an x value somewhere. So that would be a hole or a vertical asymptote. Somewhere where you divide by 0. What are the names of the types of discontinuities? Okay, now remember we just did that. So we have a hole and we have a vertical asymptote. And remember there's also a jump. And remember jumps only happen on piecewise functions. And we are dealing with piecewise functions today. Okay, here we go. Find this limit. So we have a piecewise function. We use this function whenever we're to the left of 2, whenever it's less than 2, left of 2. You use this function whenever you're to the right of 2, or when you're greater than or equal to 2. Now real quick, I am going to graph this so you can see yourself what the answer is, and then I'll show you how to do it analytically. Okay, here's the graph of it. So the x squared minus 3, that's the graph of the parabola all the way up until 2, where we have our changing function, where it comes over here to this linear function, which goes down. Now individually, we know that this function, let me grab my pen. Individually, we know that this function, the top function, is continuous everywhere. And we know that this function has no discontinuities anywhere as well. So we know that both of these have limits everywhere. So we could just plug in the number and it would tell us what the limit is. The only thing that might ruin the limit here, since there aren't holes or discontinuities, is this changing point. We changed right here, right, to a different function. Right here, we know the limit as x approaches 2. If we do this answer, we're talking about this line right here. Okay, the answer is 1. From the left and the right, from the left, we're approaching a y value of 1. From the right, we're approaching a y value of 1. So from the left, it's approaching a y value of 1. From the right, it's approaching a y value of 1. And so we know the answer is 1. So the only thing that could mess this up is this from the left being a different number than from the right. So all we need to do is plug in this number to each function, so this is the left, this is the right, let's plug in 2 here and see if they're the same number. And then we would know that the whole function of g of x is continuous. So let's plug in 2. So on the first part, we'll have 2 squared minus 3, which is equal to 1. That's from the left. So from the left, I know my parabola function is approaching 1. Now let's check from the right. We have a negative half times 2 plus 2. And that makes negative 1 plus 2 is 1. So from the right, I know that my function is also approaching a y value of 1. Since I know that they are hitting the same y value at this changing point, that must mean that the limit is equal to 1 at 2. Yeah? Now let's say they asked a different one. Let's say they asked maybe like the limit as x approaches 3 of g of x. Okay. Well, if you're doing 3, like look at it on this graph, it looks like 3 from the left it's approaching a half, and from the right it's approaching a half. So the answer would be a half. Now notice you're only using this function on the right. We're only using this function for that answer. So if you're doing like a number like 3, it'd be negative a half times 3 plus 2, which would make a negative 3 over 2 plus 2 would give you just a positive half. And that would be the answer here. You wouldn't even have to worry about this function because it has nothing to do with the number 3. Okay, let's go to the next one. Okay, so on this one, we're talking about a limit as x approaches negative 1. Now, if you notice, both these graphs, let me grab my pen. Both these graphs, this graph up here, this is the one from the left, and this is the one from the right. Both of them are continuous by themselves, so they would have a limit if we just plugged them in. It would give us a limit, yeah? But we're going to have to see if from the left of this, it has the same answer as from the right. So we're going to have to plug into these. So let's plug in here. From the left, we're going to have a negative 1 plus 3 squared plus 3. Okay, this would come out to be, this would be 2. Squared is 4. It'd be negative 4 plus 3, which is negative 1. So our y value from the left is negative 1. Let's check it from the right. Okay, we're going to plug in negative 1 into here. It's going to be negative 1 plus 2, which is going to give us 1, right? Well, from the left it looks like it approaches negative 1. From the right it looks like it approaches 1. So they don't approach the same value. So I would say that is a limit is D and E. Now let's look at the graph of that and see if we got it. From the left, I grab my pen again. From the left of negative 1, we are approaching negative 1, which is what we said, right? From the right, we are approaching a y value of positive 1, which is what we said. Since they are approaching different values from the left and the right, we have a jump discontinuity, right? This is a jump. So it doesn't have a limit at that point. Now similarly, as I did earlier, let's say I asked about the limit as x approaches, let's say, negative 2 of our function h of x. Well, look at it on the graph. Negative 2, the answer is going to be 2. Okay? You would only use this top function if you were going to do that. You wouldn't worry about the right part of the function because it has nothing to do with the value negative 2. So like let's say you're doing this one, you would just plug into that left function, negative 2 plus 3 squared plus 3. What you're going to get here is you're going to get negative 2 plus 3 is 1, squared is 1, with the negative 1 plus 3 is 2. That would be your answer. You don't even need to worry about this right-hand side of the function. You only have to worry about it if we're talking about this -1 value where it's switched. Okay, let's go to the next one. Okay, now I've provided the graph on this. So we're going to limit as x approaches -2. So let's look at the answer first with the graph. Okay, we're talking about this line right here. X approaches -2. Okay, it looks like from the left it goes to positive infinity, and from the right it goes to positive infinity. So from the left it goes to positive infinity, from the right it goes to positive infinity. So our answer is going to be positive infinity. Yeah? Let's do this problem though. So we're going to check it at -2, which is a changing point, right? So we need to plug into this one, the left-hand side, and we need to plug into this one, which is the right-hand side. Okay, let's just plug it in first. Remember, there's 3 steps. Plug in -2. So from the left, plug in -2. -2 over 2 times -2 plus 4. I'm using that top function. That gives us -2 over 0. Okay, remember, that is not good. We can't do that. Step 1 failed. So we go to step 2, factoring and canceling. But here, as you can tell, there's nothing to factor, and you can't cancel stuff. So I have to go to step 3. The answer is either going to be positive infinity or negative infinity, because we're just talking about one side. We're talking about the left-hand side. It's either going to be going up or it's going to be going down. Yeah? In this case, I know it's going to be going up, but let's check it. I need to pick a number to the left of -2, because we're talking about the left-hand side. So to the left of -2 would be -2.1. Okay? Let's plug in -2.1. -2.1 over 2 times -2.1 plus 4. Okay, remember, we don't care about the value. We just care, is it going up or is it going down? So we need to see, is it positive or negative? The top here is going to be negative, obviously. The bottom is going to be negative. It's a larger negative than 4 plus 4. This would leave us with a negative. So a negative divided by a negative is a positive. So we know from the left-hand side, we are approaching positive infinity. Okay, that's from the left-hand side. We now need to check the right-hand side. Okay, so let's plug in -2 into the right-hand side and see what it gives us. So we got a -2 minus 1 all over 2 times -2 plus 2, and that gives us, doesn't really matter on top, but it gives us a -3 over, so that's going to be positive, 0. This is going to be 0. So we can't divide by 0. Step 1 failed. We can't factor and cancel anything. It's already factored and nothing's canceling out. So that means we have to choose something a little to the right of this, and our answer is going to be positive infinity, it's going up, or negative infinity, it's going down. So let's pick a number to the right of this, which would be -1.9 would be a good choice. Okay, let's plug it in. So we got a -1.9 minus 1 all over 2 -1.9 plus 2. Okay, let's see what this comes out to. The top is a negative, and then times the negative in the front makes it a positive. All over. The bottom, -1.9 plus 2 is positive, times a positive is positive. Positive divided by a positive is positive infinity. So from the left it's going to positive infinity, from the right it's going to positive infinity. So our answer is positive infinity. Okay. So remember, always follow the steps. Step 1, plug it in. Step 2, factor and cancel. Step 3, a little to the left, a little to the right. Okay. Let's go to the last one I believe I have here. I have provided this graph as well because people mess up on this one a lot. Notice this one's different than the ones we had before. Before I was giving you less than or greater than type problems. This one is a does not equals and a equals. So notice on this graph, if you do the limit as x approaches 5 of the function, look at it and tell me what you think the answer is. Okay, limit as x approaches 5. From the left-hand side, it's approaching a y value of 10. From the right-hand side, it's approaching that same y value of 10. So we know the answer is going to be 10. Now let's come over here to this function, this piecewise, and see how this might work out like that. Now, remember, limits, we defined it earlier. A limit is what you're approaching. What you are approaching. That's the key thing. What you're approaching. We don't care about the point. This is a point. 1 point value right there. It's a point. Notice we didn't care about it when we got the limit. So we're not even be using this to find the limit. Don't use for the limit. It doesn't make sense. We're only talking about the left and the right. This function right here tells us both the left and the right. So all we need to do is plug 5 into this function, and it will tell us where it's going from the left and the right. So let's plug 5 into this function here. 5 squared minus 3 times 5. That's going to be 25 minus 15 is 10. That's the y value it's approaching. This function told us the left and the right. This function, if you plug into it, you're going to get 11, and that's just going to be where the point is. Remember, we don't care about the point. We're doing limits. We care about where it's approaching from the left and the right. And that would only be this function right here. So the does not equal sign is what you are using when you're talking about limits. That's it, guys.